Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called vertical order traversal of a binary tree. So this is the variation of the existing problem that's called binary tree vertical order traversal. So this problem I already covered last year, and this is like binary tree vertical order traversal, right? And this different one is little variation, and the additional point is this selected lines. So if two nodes have the same position, then the value of the node that is reported first is the value that is smaller. What does that mean? That means like if they are having the same position, right? So this is like vertical order traversal that we already covered, right? And let's say this diagram I'm taking from the example 2, right? From the example 2 I'm taking this example, and the same position means the same coordinates, right? So if I divide this in the vertical lines here, so they will be like these vertical lines, right? So like let's say this is 0th index, first index, second index, third index, fourth index. Okay, and if I update this diagram, like just to understand, right? So what will happen, these 5 and 6 will come under basically this vertical line, that is 2, right? So that's how they will come. So basically 5 and 6 they will overlap each other. So 5 will come here, and if I draw here, 6 will also come here, so they will overlap each other. What does that mean? They will have, these two nodes will have the same position, and then we need to have the 5 first and then 6 after that, right? So here what will be the list, like 4 is the one pair, 2 is another pair, and another pair is 1, 5 comma 6. Okay, 5 will be coming before 6 because 5 is smaller than 6, and then 3, and then another list is 7, right? So another list here is 7, right? Let's go ahead and verify. So 4, 2, 1, 5, 6, 3 and 7, right? So that's what we are seeing here. Okay, so I hope this is clear. These sorting will not happen based on the index, right? This sorting will happen based on the position, and position here is they are explaining the position is like in terms of x and y coordinates, right? But this is what it means by the position, right? So they, I mean, these nodes should have at the same position, right? And if they are not at the same position, like let's say for example I am making any hypothetical tree here, let's say 5 3 2, okay, 1, okay, 7, and then let's say this guy is again having some other value like 9 or something, okay, or let's say this value is like 0, right? So if we see here and then this 0 will basically come with this vertical line, right? And then the 0 will having like this. So now this 2 and 1 they are coming in one vertical line, right? So basically this 2 and 1 they don't need to be sorted, right? Because this is like one index, let's say this is 0 and then 1, and then this is another index, this is another index, and this is another index, 2 3 4. Okay, so this is, let's say, one hypothetical example of the binary tree here. What I'm trying to explain here is that even if they are under the same index, same vertical line, and if they are at the different level, we don't need to sort them, right? If they are having at the same position, means let's say 3 is also having one left child and it's having some value, like let's say 6 or something, then basically this pair will be 1 comma 6 that needs to be sorted. Okay, so that's the main important part of this problem that we need to understand. Otherwise, other concept like how we will do the vertical order traversal and all, that's exactly same from this example that I already covered like last year in December. So I would highly recommend that let's go through this first of all example, this video, and try to understand what this vertical order traversal is there. Once this is clear, then let's jump to this problem, and then let's add the code of these two lines. Okay, so let's go ahead and do that. I'm just copying this code, and then I'm just control A and control V. I'm just pasting the same code here, and then I'm just changing the method name, because here the method name is little different. So what we need to do, when they are at the same position, if the two nodes have at the same position, then the value of the node that is reported first is the value that is smaller. So what it means, whenever they have at the same position, two nodes are coming at the same position, then basically we need to sort them. What does that mean? We need to sort them means we need to take some priority, because we are using Java, so we can take the priority queue data structure, and with the help of priority queue we can sort these values. Okay, so that's what we will do. Another observation here is, they have, if they are sharing the same position, if they are overlapping each other, means we are doing here level wise level, right? So this is first level, this is second level, and this is third level, right? So whenever we do the level traversal in binary tree, we do the horizontally, right? So we are also going here horizontally. This is first level, this is second level, this is third level. So for each level we just need to make sure if we are covering every level, and in every level whenever these nodes are overlapping each other, means they are having the same index as well at this particular level, right? So let's say in this example, right? So if I take here control C and then control V. Okay, I'm just trying to paste this binary tree here. So in this example, right? So this 5 and 6, they are overlapping at the one index, right? So this is first level, this is second level, this is third level, and again these vertical lines are representing the different index. So let's say this is 1, or in fact if I start from here, then from the root, then this is 0th index, this is -1 index, this is -2 index, and again this is -1 index, and then this is 7, it's coming in the -2 index. We can choose whatever manner we can try to understand, right? So it does not matter, we can start from 0 from here, or we can start from the root. And in fact in our code or in our implementation, we are starting from the root and we are assigning that as a 0. And when we are going to the left side, basically we are just doing -1, and whenever we are going to the right side, we are doing +1. So basically on the right side we are doing +1 and +2. So we are incrementing by 1 every time for every index. Whenever we are going to the left, we are decrementing at by 1 to the whenever we are going to the left side. Anyways, so here what I'm trying to cover, only this part. I'm not going to cover what the vertical order traversal, how it works. For that, let's refer this video. I'm going to cover the same position and then how we are going to sort this. Okay, so we will traverse like this level, first level, and then second level, and then third level. And whenever for each level we will make sure, okay, if these two nodes are sharing the same index as well at every level, if this for example this 1 2 3 third level, if these two nodes are having the same index, then we will sort it. If they are not having the same index, then we are not going to sort. So that's the very simple thing that we need to do. Okay, now let's come to the code part here. We are already having this map, outer map. We don't need to touch that, it's okay. We will still have the map, and then we will make the same concept here itself, right? We are not going to change any concept. So in this case what we will do, because we are dealing here with each level, so this for I equals to 0 and I is less than size, what this guy is doing, this is covering for each level. So this for loop is covering whenever whatever the values, whatever the size is there of that particular queue, that's how many number of iterations this size I equal to 0, I is less than size is covering, right? So for example, my queue is having only one element, then it will be iterating only one time. If queue is having two elements for this level number 2, then it will be iterating two times. And now queue is having like these four elements or four nodes, then it will be iterating four times. So basically for every level, this for I equal to 0, I is less than size will be there. So what we need to do in this for loop, we need to put our logic, okay, because this is for each level. Okay, so let's go ahead and make one map here. So integer, this is index, and then let's take the priority queue integer, and let's say name is local map equals to new has map. Okay, now here in place of map, let's do this local map, and in place of linked list here, let's do the priority queue. Okay, and in place of add, let's replace with this offer. Okay, so now what we did, we are using here the local map for this label, for this particular label, and then we are checking, okay, if it is having the same index, then let's go ahead and sort that. So for sorting, we don't need to do anything else because we are taking the priority queue. So this priority queue data structure will take care of the sorting part, and by default it is in the ascending order, increasing order. So it will be sorting these node values. And once this loop is done for I equals to 0 and I is less than size, then what we will do, we can populate our main map, right? And how we can do that, that's straightforward. That's not just another for loop we can put here, and then we can just get that. Let's say this is index and then local map dot key set, this method. So we will be getting the index from this local map, and then we will be getting the priority queue from local map. So local map dot get this index. In fact, this is key of this map, right? But I am taking here the name is index so that it will be a little bit clear, because here we are putting the index itself in the uh, local map, right? And then map dot put if absent. What this put if absent is doing, if this particular key, if this particular value is not present, then basically it will put, otherwise it will not put, right? So what it will do, this index and then new linked list, right? So this is like similar thing, whatever we were doing here, we are now doing after this label, right? So that's the only difference. Earlier this map dot put if absent was here, now we shifted it here, right? So after this processing is done, we are done with the sorting means whenever this current index is the same for each label, for this label, right? Whatever label is there, like let's say for example here 5 and 6 were there, right? And here the label was same, index was also same and the label was also same. So in that case we are sorting, right? So if we see here, this 5 and 6, they are at the same index. So index is for example this 0, then this 5 and 6, they will also be overlapping at the 0th index and they are also at the same level. So then only we are sorting, and then we are putting it here. So now we got the priority queue. Now let's go ahead and iterate this priority queue. So pq is not equal to null and pq dot is empty. If it is not empty, then let's go ahead and populate our map. So how we will be populating our map, we will be taking this index itself. So let's go ahead and in fact this is not put, we will be getting the index. So we already put this linked list, so we will be getting this linked list, and then we will be adding this link, adding this pq dot poll to the linked list. Okay, very good. So that's it, we don't need to do anything else. Otherwise, apart from this for loop, other code is like it's existing code. So we are not changing existing code, we are not changing our concept, we are not changing our understanding, everything is exactly same. The only code we have added here for these two lines, if the nodes have the same position, then we are sorting these nodes. The smaller nodes is coming first and greater node value is coming after the smaller. So we are just sorting in the ascending order, right? So what we did, we introduced this local map. We are using same concept, like if current index does not have the priority queue, then we are putting the priority queue at only one, so that current index we are stitching with the, with this current index we are stitching multiple node values, right? So basically for example 0th node, 0th index is there, we are putting 1 as well, 5 as well, and 6 as well. So we don't want to populate different linked lists, so that's why we are using put if absent here. Similarly here as well we are using put if absent, so that index will be same, but it will be the same linked list, and then we can just add to the same linked list and same priority queue. So priority queue is nothing but it is kind of the list only. You can just consider that it is a sorted list, it's just doing the sorting for us, otherwise it's a similar thing, right? So once we this sorting is done for this particular label, then we are populating our outer map, that's it. And otherwise concept is pretty similar, and then it's pretty same. Let's go ahead and try to compile this if it is working fine. So looks like this is working fine. Now quickly, this complexity, right? So earlier it was n, now it will be n log n. And why it will be n log n? Because we are using the priority queue here. So at every index, right, so at every level, not the index, so at every level we are doing the sorting as well. And the priority queue, whenever we are using priority queue itself, let's take log n time for doing that. And in this, basically, while queue is not empty and I use less than size, basically this for loop is also n time, so it will be n log n. And then space complexity by default, because we are already taking the queue, so it will be order of n itself. So time complexity we are also increasing for this particular problem. Let's go ahead, because it was compiling, let's go ahead and try to submit if it is working. So looks like this code is working fine. Before ending this video, there are three main steps that we need to cover. First of all, before jumping to this problem, we need to first solve this problem. And to understand this problem, we need to refer this video first of all, that I published like last year. Once we build our concept like what is this binary tree vertical order traversal, then what we can do, we can solve this problem, and then we can cover to this problem, vertical order traversal of a binary tree. And the only difference is this two lines. Whenever two nodes have the same position, then the value of the node that is reported first is the value that is smaller. So in other words, in the simple words, whenever two nodes are coming at the same position, right, then we are sorting those values. And same position, what does that mean? Same position means whenever so if I increase this font itself, same position means basically if like this 2 and 2 left is 5 and 3 right is 6, so basically these two nodes should overlap to each other, basically, right? These nodes overlap each other. If we will diagrammatically, if we will see like this, right, so 5 and 6, they will overlap to each other and they are at the same level. So basically same position means they should be at the same level and they should share the same index. So basically if you are visualizing in terms of the diagram, then this basically this should be crossed, right? So vertical and horizontal lines should be crossed to that those nodes. If they are crossing each other at that particular point, then they are eligible for the sorting. If they are not crossing, then they are not eligible. For example, some node here itself and then subtree is having some other nodes here 0 1 2 or something, still 9 will come before 0 because they are not having the same position, right? Because here if you will see, vertical line is this and horizontal lines, they are not crossing each other. This is separate horizontal line, this is separate horizontal line, right? So what does that mean? This is, let's say, x label and this is like x plus 1 label, for example, right? So if they are have the different labels, then they are not going to sort. If they are having at the same level and they are sharing the same index, then only we are sorting. So this is like the main point that we need to understand. If this point is clear, then I think this is pretty straightforward. We are just taking the local map, we are sorting for this particular labels. Once the sorting is done for this particular label, then we are just what we are doing, we are populating our outer map from this local map, right? So we are just populating our outer map, and then the otherwise the concept is pretty same. So I did not cover this vertical order traversal, but I tried my best to cover these two lines here. So let's go through this. Let's follow the sequence. Let's first of all solve this problem, then come to here, and then just let me know your feedback. If it's still not clear, then I can try to clear it a little bit more. Hopefully this might be useful. Thanks a lot. Have a good one. Bye.